Hello friends, welcome to Risingpearl.com. Today we are talking about series 10 where we are learning a great deal on circles. This is webisode number 13. Today we are going to continue to look at how to solve questions involving circles and tangents. This is part 2 because in webisode 12, the last webisode, we started the part 1. So I hope you're following us along friends like we always do at Risingpearl.com. If you have any questions, queries, feel free to let us know and we will try our best to answer them for you. Now, few things to remember whenever we are dealing with questions involving circles and tangents. We looked at them in the last episode as well. So for a quick recap, we absolutely want to make sure that we understand these concepts and they may very likely be involved in solving these questions. So the first one is tangent at any point of a circle is perpendicular to the radius drawn through it. In other words, if you draw a circle, so here we have drawn a circle, and let's say that circle has a center O, and P is a point, and PA is the tangent. Now, from the first theorem, we saw that if PA is a tangent, and A is the point where the tangent touches a circle, if you draw a radius like OA, that means through the point of tangents, if you draw a radius, then this angle which is formed between the radius and the tangent is always 90 degrees. The second theorem that we learned was that, again, very, very important. Make sure that few episodes ago we actually have looked at each of these theorems. We have proven these theorems. So if you are not comfortable, please go take a look at those videos. I'm going to provide those links for your easy reference. Make sure that you're very much comfortable with these theorems. When two tangents are drawn from one external point to a circle, both of them are of equal length. So PA is one tangent. We saw earlier that from one point we can draw at most two tangents to a common circle. So PA is a tangent, PB is a tangent, then the length PA must be equal to length PB. That means if you draw two tangents from one external point to the same circle, then the length of those two tangents must always be equal. Then friends, we talked about how, because we have a right angle, there are many examples where we may need to bring in or draw upon our experience of congruent triangles. We may need to prove two triangles congruent and then use that information to solve the question. And whenever we do so, particularly this congruence rule is of great importance to us. Right angle, hypotenuse side. So we talked about that in the last episode as well. And finally, because we are dealing with right triangles, we may need to very often apply Pythagoras theorem quite a bit. So friends, again with that, these are friends, like we discussed last time, these are four of the many things, but nonetheless, four very important things that you want to keep in mind whenever you are trying to solve questions involving circles and tangents, as you may need to be using one, two, or more of these ideas while solving the questions. So now the first question is, I'm saying question 4 because it's a continuation from our last series. So question 4 is, a quadrilateral ABCD is drawn to circumscribe a circle as shown in the figure below. Prove that AB plus CD, the opposite sides, is equal to AD plus BC. So friends, few things I want to talk about when you solve questions like this. The first thing is that this term, which is circumscribe, you want to make sure you understand the meaning of this term. Circumscribe means drawing a figure around or outside another figure. So if we say that the quadrilateral circumscribes a circle, it means that quadrilateral is the outside figure and circle is inside. That is the first part. And second thing is that such that we draw a figure around another figure such that we touch the inside figure, touching it but not intersecting it. That means if you look at the figure which is given to us, we have a quadrilateral ABCD that circumscribes a circle. That means this quadrilateral is outside and circle is inside, and it is touching the circle. It is not intersecting the circle at any given point. So in other words, for example, if I give you this particular shape and ask you what is going on. So here, because the triangle is outside and circle is inside, so you are going to say that the triangle circumscribes the circle. It's very important to understand the idea of what do you mean by circumscribing, because you will see this quite a bit, the term circumscribing, right? Circumscribing means drawing a figure around, outside another figure, touching it and not intersecting it. So in this particular case, we have a triangle circumscribing a circle. So anyway, now that we understand this, let's clean this up a little bit. So what we have, so how do we solve this question? So AB touches the circle at point P. So first of all, let's name these 4 points where the quadrilateral A, B, C, D, it touches the circle. So let's say it touches the circle at P, Q, R, S respectively. Now AB touches the circle at point P. So both AP and BP are tangents to the circle. So think about this. So AB is a straight line that touches the circle with center O at point P. That means the fact that P is a point on AB, so AP and BP both are tangents to the circle, right? So similarly, we can say AD touches the circle at point S. This line AD touches the circle at point S, so AS and DS are both tangents to the same circle, right? Now we know of the second theorem, which is that when 2 tangents are drawn from the same external point, those 2 tangents are actually equal, right? If we draw 2 tangents, we know that those 2 tangents are actually equal in length. So these two, so this is a theorem that we have seen, this is a second theorem, right? Or in other words, what we have here, friends, is that, so what we can say is that AS, this length, AP, so this should be equal to this. Because from same external point A, we are drawing 2 tangents AP and AS. So these two should be equal. So this is our first equation. Let's call it equation number 1. So similarly, DS equals DR. So DS, this length, should be equal to DR. Because again, these are 2 tangents drawn from the point D. So you can say the same thing for every other point, that is for point B and for point C. So we can say that similarly, BP equals BQ. So let's call this second one our equation number 2. Then we have third one equation 3. So these two are equal. So these 2 lengths are equal. And finally, these are all equal. I just wanted to make one quick point. Let's call the last one as equation 4. I want to quickly remind you to the fact that now this and this length are equal. So this and this length are equal. But please do not misunderstand that AP somehow is equal to BP. Because we do not know any information between AP and BP. We know that because AP and AS are both starting from the same point, they are tangent to the same circle, so they are equal in length. But there is no information given between AP or BP. Similarly, for that matter, BQ and BQ and CQ, or CR and DR, right? So it's very important to keep that in mind. Now, so what we have here, friends, is that so you now would want to add this, meaning you want to add equation 1, equation 4, equation 2, equation 3 and equation 4. So now the way we are going to add this is, we have AP, right? Then so AP equals, so in other words, you think about it this way. So you have AP equals AS, right? AS. So next we are going to write BP, which is equals BQ. BP equals BQ. Why am I not writing BQ equals BP? Same thing, because I want to add them, so I want to get AP plus BP, because I am trying to get eventually the sides of the quadrilateral AB, CD, AD and BD. So I do not want to add AP and BQ. I want to add AP and BP. So similarly, so we talked about these two. Now how about this and this? So similarly, we have here, let's write, because we want to prove AB plus CD, so CD can be written as DR. So let's write DR. Now DR, which is this length, is equal to DS. I'm just rewriting those four equations, and which is left is CR, which is equal to, which is this length, is equal to CQ. So now simply adding these equations, what we will get is, we will get AP plus BP plus CR plus DR, which will be equal to AP plus BP is equal to AS plus BQ plus CQ plus DS. So now we are just going to rearrange this. So AP plus BP equals CR plus DR, and here instead of AS plus BQ we are going to write it as AS plus DS and BQ plus CQ. AP plus BP is nothing but AB. CR plus DR is nothing but CD. So on the left side we have got AB plus CD, like we want to do, AB plus CD, equal to AS plus DS is nothing but AD, and BQ plus CQ is nothing but BC. Hence we have actually proved that indeed if a quadrilateral circumscribes a circle, then sum of opposite sides AB plus CD is indeed equal to AD plus BC. So friends, in this particular question we really made use of, if you think about it, only the second theorem of circles, which is the tangents drawn from same external point to the same circle, are both tangents are of equal length. But it is important for you to understand like how your mind needs to think when you look at the questions on circles and tangents. That is, you are always thinking about, so even if there is no mention in the question about tangents, a quadrilateral is drawn circumscribing a circle, you are really thinking about where you can use tangents, how you can use radius, and how you can use 90 degrees, so on and so forth. So now let's take a look at one more question probably. So here what we have is, in the figure below, x dash, xy and x dash y dash are two parallel tangents to a circle with center O, and another tangent AB with point C of contact intersecting xy at A, x dash y dash at B. Prove that angle AOB is 90 degrees. So a lot of things are going on. So let's break it down. So first of all, xy and x dash y dash are two parallel tangents. This is interesting. So two parallel tangents. So first we draw ourselves a circle with center O, and then we draw one tangent like this. Let us call this, let us say this is xy. So this is a tangent xy to the circle O. Now there are two parallel tangents, meaning this is a tangent and this is another tangent. We draw another tangent x dash y dash. This is a second tangent which is x dash y dash, right? So we have, the unique thing about these two lines are, so both xy is a tangent to circle O and x dash y dash is also a tangent to circle O. But the unique thing is these two lines are actually parallel to each other. This line and this line are parallel to each other. That is a very interesting observation. In addition to that, and another tangent AB, and AB is another tangent to the same circle with point C intersecting. So this is a tangent at point C here, intersecting xy at A and x dash y dash at B. Prove that AOB is 90 degrees. So first what we are going to do is that we are going to simply join. So we have, this is point C. Also the point where xy is tangent, let us say this point is P. And let us say the point where x dash y dash is tangent is point Q. So we have now point P, point Q. So at point P, xy is tangent to the circle. Point Q, x dash y dash is tangent to the circle. And transversal AB is also a tangent at point C. So now we simply join O and C. Now we join O and C like this. Now at this point, friends, I want to tell you, you can solve this question in a few different ways. So I'm going to, there is more than one way in which you can solve this question. So the most straightforward way, or one of the most straightforward ways, is that we have been seeing how whenever we have this situation where we have an external point and we basically draw two tangents, AP and AC, right? And when we join OP and OC and we join OA, then we have been seeing that these two triangles are congruent by RHS congruent rule, or the fact that because this is 90 degrees, right, and this is 90 degrees, because OP is perpendicular to AP, tangent and radius, and OC is the radius and AC is the tangent. So this angle is 90 degrees. Also we know that this is the radius of the same circle, and then we know that AP, this side, is equal to AC because they are tangent from the same point A on the circle, two tangents from same point A. So again we can say that these two triangles are congruent, right? In this case we can say by side angle side, so by ASA rule or SAS. So we say that triangle OPA is congruent to triangle OCA by SAS congruence rule. We could have actually said that OA is common, so it could be SSS congruent rule or RHS congruent rule. So it doesn't matter. But the fact that because these two triangles are congruent, what is most important is if this angle is X, this angle is X. If this angle is Y, then this angle is Y. Right? This is the most important part. So similarly, we can say that between these two triangles, so if we look at this triangle and this triangle, these two triangles are congruent, right? And because these two triangles are congruent, what it means is that these two angles are equal. So if this angle, let us just say this angle is Z or Z, so this angle is Z or Z. So now if this is the case, right, so what happens is, yeah, obviously these two angles are equal as well. But now think for a moment. So now if you look at this line AB, this is where we are going to use this information that the two lines are actually parallel tangent. That is XY and X dash Y dash are two parallel lines. If XY and X dash Y dash are two parallel lines, then AB is a transversal, and hence this angle, this whole angle should be equal to this angle because alternate interior angles are equal, remember. So we have angle PAB, let's call it angle PAB, is equal to angle ABY dash. Why is angle PAB, which is this angle, equal to ABY dash? Because they are alternate interior angles. AB is a transversal and these two are parallel lines. So from here, PAB is actually 2y. It is y plus y. And for this angle, this particular angle, we can write this angle as 180 degrees minus this angle, or 180 degree minus 2z or 2z. Let's take the minus sign on the other side. So we will have 2 times, let's take 2 common, y plus z equal to 180 degrees. right? So the 2z or 2z goes on the other side. And now from here, we can take the 2 common factor out. You will get y plus z is equal to 90 degrees. Now, if you look at this particular triangle, so if you look at this triangle AOB, so if you look at triangle AOB, right, AOB, so angle AOB, so angle AOB, what we need, this angle, so this angle plus y plus z or z is 180 degrees, because sum total of 3 angle in a triangle is 180 degrees, but we know that y plus z is 90 degree. That means that angle AOB must be equal to 90 degrees, and hence we have proven the fact that this angle is indeed 90 degrees. So friends, this is a question where we used quite a few different things, but again somehow we had to use the fact, so 2 tangents drawn from same point, those 2 tangents lengths are equal. We had to use the congruence triangles, and we had to use some of the basic geometry aspects in solving this question. Let's take a look at maybe one more question before we wrap up. So let's call it the third and final question for this particular video. So we have 2 concentric circles are of radii 5 cm, 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. So there are no shapes or figures given to us. So friends, again, like I had mentioned earlier, we have to be very carefully, we have to understand what the question is saying and then draw the figure appropriately. So first thing is that we have to draw 2 concentric circles. So what do we mean by concentric circles? So concentric circles are something like this. So here we have the same center O for the smaller circle, right? So this is our smaller circle. So let us say this radius is R1 for the smaller circle, and then we have, let us say, this radius R2 for the bigger circle. So concentric circle means same center. So circles with same center are called concentric circles. So we are looking to draw 2 circles with the same center. So the smaller circle has a radius of 3 cm and the bigger circle has a radius of 5 cm. This is given to us. Next, find the length of a chord of the larger circle. So we have to find the length of a chord of the larger circle. So now if you think about it this way, so what I have here drawn is that I have actually tried to highlight the outside circle like this, and this is the inner circle, and then these are the lines, that is, let's name them, say AB, CD and EF. I have drawn randomly some chords. Remember that chord is nothing but a straight line joining 2 points on a circle. We are looking to find a chord of the larger circle. So we are looking for something like AB or CD or EF, because each one of them, they are chords of the larger circle. But we are looking for such a chord that actually touches the smaller circle. So in this, which is the chord that actually touches the smaller circle? Clearly it is not CD, because it is intersecting the smaller circle at 2 points. It is not EF, which is intersecting the circle at 2 points. But we are looking at a chord something like AB. So in other words, we want to have something like this. So we are looking for a chord. Now it could be this chord, it could be this chord, we don't know which one. But it is a chord in the larger circle in such a way that it touches the smaller circle, and then we have to find out the length of this chord. So all these chords will be of the same length, so it does not matter which one you draw. So just for the simplicity, we are going to actually go with this particular chord. It will be just easier for us. Now we know that this chord actually touches So we have, it's a chord, so there will be 2 points on the circle, bigger circle, where the straight line touches. So let's name them. So let's call this as A, let's call this as B, and then this actually touches a smaller circle. Let's call this as C. So now what we do is we have 3 points A, B and C. We will do a small construction. We are going to join the center O with each one of these points, and we will get something like this. So now so we have drawn the concentric circles, 2 concentric circles. We know what is given is that OA is 5 centimeter, which is the radius of the larger circle, and OC is 4 centimeter. OC is 4 centimeter, radius of the smaller circle. Now we have to find the length AB. So friends, we have done earlier, we have seen how we can, actually the way you're going to do this is, the first thing is that now this is 90 degrees. Why? Because AB is tangent to the smaller circle and OC is a radius. So from the first theorem, this is 90 degrees. So we know that OCA is going to be equal to 90 degrees. So that means the triangle OCA is right triangle. So applying Pythagoras theorem, we can say that OA square is equal to OC square plus AC square. So OA is the radius of the outer circle, so that is 5 square. Now OC square, OC is the radius of the smaller circle, inner circle, that is 4 square. Actually it is 3 centimeter, so it should be 3, not 4. So there should be 3 centimeter, 3 square plus AC square. So from here we say that AC square will be equal to, so 25, 5 square is 25, minus 3 square is 9, goes on the other side, minus 9, or 16. So AC is square root of 16 or equal to plus 4 or 4 centimeter. So this length AC is 4 centimeter. Now if we look at these 2 triangles, which is this triangle and this triangle, that is in triangles OCA and triangle OCB, if we look at these 2 triangles, we can prove that these 2 triangles are congruent. So OA is equal to OB, both are radius of the outside circle. OC is a common side, and this angle and this angle are 90 degrees. So by RHS, congruence rule, we say that these 2 triangles are congruent. That means that AC should be equal to BC. So now we have to find out the length of the outside chord, right? So we have to find out the length AB. This is what we have to find out. So we just saw that AB, which we can see from the diagram, is equal to AC plus BC. Or we can say that AC equals BC. They both are equal, so they both are 4 plus 4, or this is equal to 8 centimeter. And hence we can say that the length of the chord in the larger triangle that touches the smaller circle, that length is 8 centimeter. So friends, I hope that you are seeing how we have covered quite a few different types of questions on circles and tangents, and how we approach these questions, how we solve them. Like we always say at risingpearl.com, if you have any questions, please feel free to ask and we will try our best to answer those for you.